Assalamu alaikum. My name is Haider Said Khan, and I am here with my two group members, Hassan Ali Vijnani and Muhammad Usman, to present our FIB project. Our FIB project is a data management and governance platform that we have made in collaboration with STEM. In a world where decisions and AI models rely on clean, trusted data, DataVeritas helps organizations and individuals or independent researchers ensure data quality and control. It lets users upload datasets, define complex quality rules, and manage access so that people can confidently use the right data the right way. Existing tools often lack support for complex rule logic or a clean interface. They offer limited access control or they don't scale well for large data sets in collaborative settings. They may be also expensive enterprise solutions. So we have built this tool. So the first feature we will show you is search feature. Let's say a new user comes in, he has not made an account. He has the opportunity to explore the data sets that have been uploaded, the dataset name, with a quality score, the tags, and who has uploaded it. Based on, they can also put on certain tags and filter the data sets by file type, file size, owner, column tags, or tags. As a demonstration, I am filtering by tags, so you can see only the relevant data set shows up. All right. Now we have further features where a non-logged in user can see the tags that have been placed on the dataset, the column tags, but he can obviously not preview what the dataset is. He can view the quality rules that have been done, and he can also view the profiling that has been carried out on the data set, but he cannot run any of these things since he has neither the privilege nor the account. Okay, so now the new user decides that he likes the platform. So he will now create an account. So once the account is made, the user can then log in. Now, as we can see, the user doesn't have any data sets uploaded so far. So he can have the option to upload data set, for example, uh, related to the Titanic. Now we have tested, while we have marketed the limit of 500 MB, we have even managed to upload larger files, and those are also can be uploaded and processed. So over here, we can set the column types. For example, I can set the age column type to an integer. I can set the, let's take another big age column. I can set it to double, etc. And then I proceed. And then as we can see, the dataset name, the relationship, we haven't put any tags so far, but the uh, column tag, column information like column type and column tags is visible, and the dataset preview, since we are the owner, is also visible. So the bread and butter of our project is the rule engine. As we can see, we have the columns here and we have functions here. These utility functions that we can nest and use to create complicated nested rules that will be executed. Let's take any rule, any column, and see how many values of the age column, as a very simple rule, are less than 5, as in they are children, or less than 10. The rule is compilable if at any point we can, for example, add anything that makes it non-compilable, we will see in real time. So in real time, we can judge whether it is compilable or not. We will add the rule, and the result will be the number of columns, percentage of columns in the entire rows in the dataset that are compliant with this particular rule. The way the rule works is, as I explained, is that first of all, the query that is taken up is converted into a nested representation uh, uh, that replaces these less than, greater than, equal functions with nested representations. And then a parser forms a tree-like structure for this entire query, for each query, after which A post-order traversal is executed on the data from the CSV file, which will then give us the final answer of how many rows are compliant. Uh, then we see the profiling feature where we run the profiling and we can see the values. For example, big age, as you can remember, was set to double. We can see its how many zeros it has, how many percentages, its distinct counts, mean, median, modes, variance, etc. And for string, for example, cabin, we can see the min length, max length, and particular string profiling for these fixed functions. Finally, we also have tags. We can add these tags, and this will basically mark our data set, which will make it easier to search. Uh, as we can see over here on the overview page, these tags will be visible over here. And on the explore page as well, we can see that that is being shown with the relevant tag. Of course, if I go back here, I can also show these permissions where we can see pending requests and active permissions. I can also grant multiple people access. So we have a preview access that allows the user to view the first 50 rows of the data, a download privilege that allows the user to download whoever we are giving it to download the data set, and finally the collaborator privilege that allows a user to the given user to uh, add the data set, that to collaborate on the data set. In preview, 50 rows, download, they can download, and collaborator, they can run rules and carry out profiling. I can say 2 days, and I can grant them the respective privilege that will be shown. To further explore the access control feature, let's take a data set for this user that he has not been given any access to. And we can see the data set tags and the column information, but as you can see, very importantly, we cannot see preview. We can see any quality rules that have been run, but we cannot run quality rule ourselves. We can see the profiling, but we cannot run the profiling ourselves. So while a main user owner can give access as well, we can also request a specified access from a user. And this will obviously also show up in our global permissions page as well, that we have requested access for the particular user. As you can see down here, outgoing permissions. Now I will be getting the access. My friend in the background, he will give me access from his account. And as you can see, he has clicked the accept and on this very application as well. And finally, we have this collaboration. I have this. So now I can preview the data. I have access to download the data set as well. So I can download the data set. I can run quality rules. So for example, I can run a rule, sales profit ratio. As you can see from this query, the greater than, division sign, and less than, these are all replaced and converted into nested representation. Then the nested representation of the entire query will be, as I said before, parsed in a tree and then or executed post-order traversal in post-order traversal with all the data. And what we will get in the end is a rule with the information. This global counter will be updated. Profiling I can run as well, but it is run previously as well. And I can also on my own add any tags. So tag one, let's say, and that can be added, and that will also be part of our feature now. So these are all the various access controls, and access control, as I've shown, can be either requested or given by the owner at large as a mask share. Okay, in the meantime, while I was showcasing the access control, we can see here that my friend also sent an access request because I have uploaded a new Titanic dataset as shown. I can accept or I can reject this request. So I will accept and I can grant access for as many days as I want to him. So that way he can have the access, and as you can see, that comes in the active permissions. Furthermore, another feature for my dataset or any collaborated dataset is that I can edit the dataset as well, whereby I can replace the dataset that is present over here. I can add new columns and remove any columns I want locally and then replace the dataset over here. What that will do is that any columns that have been removed will be removed. Any columns preserved will have their tags preserved. The quality rules will be preserved in that case, But what will happen is that they will have an option to be rerun and they will be validated before rerunning, and the profiling will also be cleared for that specific edit feature. We also have a delete dataset option that deletes all data and quality rules, profiling, tags, etc. Finally, we would like to thank IBA, our advisor, Ms. Maria Rahim, and Estera for the opportunity to conduct this project. As a further note, I would like to add that to demonstrate the extensiveness of our rule engine, uh, we were asked by Stella to implement 60 or so functions that the user can use along with various operator functions like plus, multiply, and or other Boolean operators. So this is the list given to us by Stella. It includes conversion functions, logical functions like is null, etc., mathematical functions like max, rounding, floors, and regex functions of getting rejects, matching, or replacing, and string functions like trimming, lower, upper, substring, replacing, reverse, etc. These each of these functions can be implemented by the user in the rule. Can be basically called by the user in the rule engine, and the user can provide either his own arguments to the function based on the or based on the input parameters. It can either be a user provided value, or it can be a column name, or it can be the output of another function. We do nesting based on the various combinations of what it could be, as in like user input value, like a string or a date or any column name, or an input output of another function as input to an outer function. Various implementations have been put by us to correctly follow our path. For example, if a single value is provided, then a single value will be output. But if a column is, for example, given as input, then each the function will be applied to each row of the column. And that way we have uh, these utility functions that can be nested together to form complicated